Hello everyone, this is Rakesh here and welcome to the session of design pattern. So what we will discuss in this session? In this session we will discuss the bridge design pattern. Also we will compare the bridge design pattern versus the conventional coding, and then we will see the example, and at last I will give the assignment for the same. Okay, so let's begin with the session. So before I start my today's session, I would like to discuss my requirement. So what is my requirement? I want to draw shapes and I want to color it. So how can I do it? I can achieve with the help of two approaches. Okay, which is our first is our conventional model. Second is using my bridge design pattern. Okay, so let's discuss one by one. First, I will discuss the conventional model, and then I will later on jump to the bridge design pattern. Okay. So you can see here I have drawn one diagram. In that I have created one interface. Okay, and from that interface I have created the three classes are derived shape classes. Okay, and that shape classes is inheriting their color classes. So now you can question that what is the problem in that. Okay, so I will tell you guys. The first problem, the number of classes is more. Since the number of classes is more, so executable size is also increased. Okay. Third, no clear code. Okay. Fourth, this code is tightly coupled with the client code. And fifth, there is no runtime binding is achieved here. Okay. So these are the problems associated with the conventional code. So how can I overcome from this problem? We can overcome from this problem with the help of bridge design pattern. Okay, so let's moving on to the next, which is our bridge design pattern. So what is the bridge design pattern? Bridge design pattern is used to decouple a class into two parts, abstraction and implementation, so that they can grow independently. So this is the definition of the bridge design pattern. Okay. So let's understand this definition with the help of one example. So you can see here I have drawn one diagram. In that I have created one interface, okay, of color interface, and then other is shape interface, and in between that I have drawn the bridge class. So now you can see there are both the interface can grow independently. And my definition also says that the abstraction and the implementation can grow, should grow the independently. Okay, so this is the bridge design pattern. Okay, so this you will understand more in the when we will discuss the example. Moving on to the next, when to use. So when I want to decouple the class into two parts, abstraction and implementation, and the abstraction should grow, abstraction and implementation should grow independently. In that case I use the bridge design pattern. Okay, and second, what I will say, I want to design a two system in a such a way that they can grow independently. In that case I will use the bridge design pattern. Okay, real time this example we will discuss in the our next videos. Okay, moving on to the next, which is your example. Okay,
so guys, my requirement is to draw shapes and I want to color it. Okay, and I want to keep in mind that in future the color and shapes can be grown. Okay, so I want to do the coding for the same. So let's understand that coding with the help of one diagram. So what I will do, I will create two interface, color interface and shape interface. Color interface have a concrete classes red and green, and the shape interface have a concrete classes rectangle, square and circle. Okay, and in between that the bridge class will come into the picture. Okay, and I will pass the object of this color to this bridge, and after that object will be used here, and I will call this color it and draw it function from the main. So let's see with the help of that coding. You will understand this more in the when we will discuss the coding part. Okay, So guys, as discussed, I created one interface field color. Okay, from that there are two classes, green color class, concrete class, and the red concrete class. Okay, and inside that I have created two field color. Okay, now I will create one shape interface, and after that I will create one bridge class, and that bridge class will inherit the shape class. Okay, and I created one object, constructor here, and it is taking the parameter as a field color, as I told you. Okay, and I made it this I created one pointer of field color, and I made it as a protected because I want to allow this pointer to be accessed in immediate class, inherited classes, I would say. Okay, so now what I will do, I want to create the shapes. So I will create a class the shape. Okay, square shape, and it will inherit the bridge. Okay, now what I did here, I created one constructor. Okay, and in that constructor I am taking as a field color as an argument. Okay, object, and that object after that, before that, what I am doing, I am calling the constructor. Okay, bridge constructor, and with which object, field color. Okay, whatever I will pass to this constructor, that object will be passed to this bridge constructor, and first this object will be initiated, this code will be triggered. Okay, or I would say that this part will be triggered. So this color will be color of obj1 be initiated first, and then later on this classes will be executed if I want to call. Okay, so this color obj1 is initiated with this obj. Now in the same way I have created the rectangle. Now let's see the client side code. Okay, so at client side what I did, I created one pointer of the shape interface, and I created the object of red and green color classes. Okay, now first use case. So first use case, I want to draw a square. So of course I have to create the square class object. Okay, and I am passing red. So I want to color square with the red. Then what I need to do, I need to pass a red object. Okay, so as soon as this object, this line will execute, so what will happen, the control goes to this here. So here the obj1 now pointing to the red class. Now this line will be executed. Okay, so this line will be executed, so this code will be get executed. So this code will be executed means now this obj is pointing to the red, so here also red, so this color obj1 is also pointing to the red. Now what will happen now, so this now I assign this object to the shape obj. So now what will happen, so this is now pointing to the square. Okay, square, this object of this class. Okay, now I'm calling the color function. So now I will call this color function. So inside color function, which function is get called field color. Okay, now this obj is pointing to the red color, so field color will be called from the red color. So the color is drawn with the shape is drawn with the red. Now shape obj is pointing to the square, so draw will be square. Okay, in the same way I will pass the green, so it will color with the green and it will draw the square. Another use case, I will create the object of rectangle, and I will pass the object of red, so the rectangle will be filled with the red. Okay, so whenever I call the color function from the rectangle class, then it will call the field color of red. In the same way this. Okay, so let's execute this example. So you can see here the use case 1. First it is get initiated with the bridge classes. Okay, so it is red color and square color. Okay, after that so this is for this line. Okay, cool. Now this is coming from this line. Okay, so and from this part is coming. So now you can see my abstraction and the implementation is not tightly coupled. Okay, so this, if I want to introduce a new shape, then I can easily create one more class here, okay, with some triangle, and I can call this red or green, whatever I want to fill it, I can fill it. Okay, otherwise what I can do here, if I want to introduce a new more fill color, then I can also create one new class with the another blue or something like that, any color I can create one more class. Okay, so but if I will follow the traditional approach, then what I need to do, I need to inherit these classes to that shape. Okay, so unnecessary it is. If I introduce new color, okay, let's say for example blue color, then and if I want to color it with the blue color, then I have to call it 2 times. Okay, 2 times here. Here in rectangle also I need to color it, here also I need to inherit that object. Okay, so that is not the feasible. Also we cannot achieve the dynamic binding. Here we can call the dynamically wherever we want, whenever we want. Okay, so this is all about the example bridge design pattern. Okay, and I'm using right now here the online compiler, and the link of the online compiler has given in the description box. Also you can download the code from the link, and the link has given in the description box. Okay guys, and guys, this is the typical UML diagram of the bridge design pattern. Okay, so here you can see the abstraction and the implementer and the concrete classes of concrete, implementer and defined abstraction. Okay,
moving on to the next item, which is your benefit. So you can see here the number of classes is less. Since the number of classes is less, so the executable size is also less. The clean code, okay, and interface and implementation can grow independently. Okay, loosely coupled with the client code, and at last we can achieve the runtime binding. Okay, so these are the benefits of the bridge design pattern. Okay, moving on to the next item, which is your assignment. So what assignment says? Implement a video player which supports 6 file format and run in 3 different operating system. And keep in mind that in future the new OS or the new file format can be introduced. So this is the one real-time example of the bridge design pattern. Okay, I hope you guys enjoyed my video, and if you liked my video, then please hit the like button, share it and subscribe to my channel. Thank you for watching my video. Bye bye, take care.